Geometry, Unit 7, which is Chapter 5 from the book, Section 7, Proving Quadrilateral Properties. We're going to be using flowchart proofs to walk through everything that we're going to be proving here in this lesson. So here, we're given a parallelogram, ABCD, and we're going to prove that the opposite angles of a parallelogram are congruent. So first step, ABC is a parallelogram. That was given to us. And then AB is parallel to DC. AD is parallel to BC. That is a property of a parallelogram. So property of a parallelogram. I'll abbreviate. Now, we know angle A plus angle D adds up to 180. Angle C plus angle D add up to 180. Now, why do we know that? We know that because those are same side interior angles given a transversal and parallel lines. Now what we can do is we can do a little bit of math. Subtract D on both of those to the other side, and we end up with angle A is 180 minus angle D. Angle C is 180 minus angle D. That's just subtraction. And then a little substitution, and we get angle A equals angle C. So I showed that angle A is congruent to angle C, and then I can do the same process to show that B is congruent to D. And there we go. We just showed that opposite angles of a parallelogram are congruent. Next, we're going to prove that the diagonals of a rectangle are congruent. I'm sorry, this should say given a rectangle. A, B, C, D. Same here, that should say rectangle. That's what was given. All right. So, given that, we know that AD is congruent to BC, and then DC is congruent to AB. That is a property of a parallelogram. Again, I'm abbreviating here. We then know, on a separate stream of thought, that all of our angles are 90 degrees. That is because it's a property of a rectangle. I'm abbreviating there. So given that, we can do Pythagorean theorem. In other words, AD squared plus, the measure of AD plus the measure of DC squared equals AC squared. And then we do the same thing. The measure of BC squared plus the measure of DC squared equals BD squared. And that is just Pythagorean theorem. Now, since we know AD is congruent to BC, we can do a little bit of substitution and get the idea, get it here, then that the measure of AD squared plus the measure of DC squared equals AC squared. And then the same thing, the measure of AD squared plus the measure of DC squared equals BD squared. Substitution. And then one more set of substitution. AC equals BD. And there we go. We proved the diagonals of a rectangle are congruent. Last one. Let's prove the diagonals of a rhombus are perpendicular. So we're given rhombus A, B, C, D. And now let's prove that the diagonals are perpendicular. So first off, let's start off with the idea that angle A plus angle D adds up to 180. Well, why do we know that? Because it's a property of a parallelogram. Next, we know that the diagonals bisect the angles. So we end up with angle BAC plus angle, sorry, not plus, that's congruent. Angle BAC is congruent to angle DAC. It's congruent. And then angle ADB is congruent to angle CDB. So those angles are congruent. So that means angle BAC, sorry, DAC angle DAC plus angle ADB equals 90. Thus, angle AED has to equal 90. And there we go. We just went through and proved that the diagonals of rhombus are perpendicular. And that is the end of this lesson.